In this section, we will look at the applications of thin layer chromatography as well as its advantages and disadvantages. TLC can be used in the lab to determine the chemical composition of a sample. But in order to do this, we must first have an idea of what chemicals might be in the sample as well as their RF values. TLC can also be used to establish solvent systems to be used in column chromatography. Column chromatography is a technique used to isolate and purify compounds from a mixture. The stationary phase is usually silica, which is packed into a glass column, and the mobile phase would be organic solvents. Before running a column chromatography, TLC can be used to first determine what solvents can be used to give a good separation of the different compounds within that mixture. Then this solvent would be used for the column chromatography. If you would like to learn more about column chromatography, feel free to look up these links. In pharmaceutical analysis, TLC can be used for qualitative identity tests. TLC is often used in British Pharmacopoeia monographs as a basic identity check on raw materials of the drug substance. Remember that this is just a basic identity check. TLC cannot really confirm the identity because there can be many compounds with similar RF values. For extra confirmation of the identity of the substance, we can repeat the TLC using different solvent systems as well as using different spray reagents. TLC can also be used in limit tests for impurities in pharmaceutical raw materials as well as formulated products. Let's take a look at two examples of limit tests. In some limit tests, the structure of the impurity is known. These impurities could arise from the manufacturing process, or it could be degradation products of the drug substance. A TLC is run with a sample and a standard. The sample is a concentrated solution of the analyte, and the standard would be a dilute solution of that known impurity. One example is the limit test for hydrocortisone in hydrocortisone acetate. Here, the drug substance is hydrocortisone acetate, and the impurity is hydrocortisone. A standard solution containing 0.01% of hydrocortisone is run alongside the sample. The intensity of the hydrocortisone spot in the sample is then compared to the intensity of the hydrocortisone spot in the standard solution to see whether it passes or fails the limit test. Just a note here, if you are looking at a real TLC plate, you will be able to observe both the size and the intensity of the spot, which corresponds to how much sample there is. However, in the illustration, we can only look at the size of the spot, so let's assume that the intensity is also correlated with the size of the spot. In some limit tests, the structure of the impurity may be unknown. This could occur when the compound has a natural or partly natural origin. For example, the compound could have been extracted out from a plant, and a number of other compounds that are structurally related to the test substance are extracted together with the compound. One example for this is alkaloid impurities in codeine. In this limit test, the impurities that could be in the codeine sample are not known. So instead of comparing the intensity of these impurities to the intensity from standard solutions of the impurity, standard solutions of codeine are used instead. So the intensity of the impurity spots on the TLC are compared to the intensity of the standard solutions of codeine. This method uses an underlying assumption that these related unknown substances, which are the impurities, would produce a similar intensity of spot to the test substance itself, which is the codeine, at equal concentration. TLC has many advantages. It is a robust method, which means it can withstand some variations in the method, and it is also a cheap method. There are also various chemical reagents that can be used for the visualization of the TLC spots. Each individual reagent or method cannot detect all substances, but Since there are many different reagents and methods available, most compounds can be detected using a suitable reagent. Also, all components on the TLC plate can be seen. For example, even if there was a spot that did not move at all on the TLC plate because it adheres so strongly to the stationary phase, that component can still be seen on the TLC plate. So there is no risk that some components are not observed because they do not elute from the system. This is in comparison to gas chromatography and high-performance liquid chromatography, where if the compound does not elute from the system, it would not even be detected. TLC is also a flexible method because the TLC plates can be treated with a variety of chemicals to give it different properties. For example, we have seen that silica can be treated with KOH or can be treated with silanes. Although we often do TLC manually in the lab, batch chromatography can also be used and it can be automated, which increases the speed of doing TLC. However, TLC also has its limitations. The sensitivity of TLC is limited because at very low concentrations, the compound may not be visualized on the TLC plate. TLC is also not suitable for volatile compounds because if the volatile compound evaporates off the TLC plate, then it also cannot be detected. Finally, TLC also requires more operator skill for optimal use compared to HPLC. Since TLCs are often conducted manually, the operator needs to have a certain level of skill when handling the TLC and the reagents.